Hello and welcome to MRCPsych on the Go Revision Essentials. My name is Dr. thalamus and I'm a psychiatry trainee in the west of Scotland. Like many of you, I spent a lot of time commuting. This was valuable time that I could have spent revising for the MRCPsych examination. And so, I've started this podcast to help you revise on the go. Each episode breaks down one high-yield topic mapped to the syllabus. This is then followed by 5 questions to help reinforce your learning. So, grab your headphones, turn travel time into revision time, and let's get started. Imagine you're walking alone at night, and you hear footsteps behind you, your heart pounds, you freeze. At the very same moment, fear washes over you. Not after the pounding, not because of it, both at once. That, in a nutshell, is the Cannon-Bard theory. In episode 22, we explored the James-Lange theory, which proposed that emotions are the perception or lag behind bodily changes. The body reacts first. The feeling follows. But not everyone was convinced. And the most important critic was a man named Walter Cannon. Walter Cannon was an American physiologist at Harvard Medical School. Born in 1871 in Wisconsin, he was one of the most influential figures in 20th century physiology. He coined the phrase fight or flight to describe the body's sympathetic response to threat. He also developed the concept of homeostasis, the idea that the body constantly works to maintain internal stability. He was a meticulous experimentalist, and he found the James-Lange theory logically and empirically unsatisfying. Working with his doctoral student Philip Bard, Cannon developed an alternative theory. Philip Bard was a young neuroscientist whose animal experiments would provide the crucial evidence the theory needed. Bard went on to become a distinguished neuroscientist at Johns Hopkins, and the theory rightly bears both their names. Remember, the Cannon-Bard theory was developed by Walter Cannon and Philip Bard. Cannon coined fight or flight and homeostasis. Bard provided experimental evidence through animal lesion studies. Before presenting their own model, Cannon set out 4 specific objections to the James-Lange theory. First, separation of the viscera from the central nervous system does not abolish emotional behaviour. In animal experiments, when the spinal cord was severed to prevent visceral feedback from reaching the brain, emotional responses were still observed. If emotion depends on perceiving the body's changes, cutting off that feedback should eliminate emotion, but it did not. Second, the same visceral changes occur across very different emotional and non-emotional states. Fear, anger, cold temperatures, and vigorous exercise all produce similar patterns of sympathetic arousal. If emotion is simply the perception of visceral change, how do we distinguish fear from the feeling of running for a bus? Third, the visceral organs are relatively insensitive structures. The gut and internal organs have far fewer sensory receptors than, say, the skin or the muscles. Cannon argued that the viscera simply do not have the sensory resolution required to generate variety of human emotional experience. Fourth, visceral changes are too slow. Physiological responses in the internal organs develop over several seconds, but emotional experience is almost instantaneous. By the time the visceral response is developed, we have already felt the emotion. Remember, Cannon's 4 criticisms of James-Lange are: visceral separation does not abolish emotion. Visceral responses are non-specific across emotional states. The visceral organs lack sensory precision, and visceral changes are too slow. Having rejected the James-Lange account, Cannon and Bard proposed an alternative model centred on the brain. They proposed that when we encounter an emotionally significant stimulus, sensory information travels first to the thalamus. The thalamus is a structure deep within the brain that acts as the brain's main relay station for incoming sensory information. From the thalamus, the signal is sent simultaneously in two directions. First, upwards to the cortex, producing the conscious subjective experience of the emotion. Second, downwards to the hypothalamus and the body, producing the physiological response. According to Cannon and Bard, both pathways are activated at the same time. The felt emotion and the bodily response occur simultaneously, not in sequence. This stands in direct contrast to James-Lange, which insisted the body responds first and the feeling follows. Remember, the Cannon-Bard theory proposes that the thalamus simultaneously activates the cortex, producing the subjective emotion, and the body, producing physiological arousal. Both occur at the same time. A useful way to remember this is to think of the B in Bard. B stands for both. Both the emotional and the body response happen together. Despite its influence, the Cannon-Bard theory has important limitations. First, later research identified structures beyond the thalamus as central to emotion. The amygdala, a small almond-shaped structure in the temporal lobe, is now understood to play a critical role in emotional processing, particularly for fear. The thalamic relay model that Cannon and Bard proposed proved to be a significant oversimplification. Second, the theory does not explain how different emotions are differentiated. If the cortex receives a simultaneous activation signal from the thalamus, what determines whether we experience fear rather than sadness or anger? Cognitive appraisal theories, which we will explore in the next episode, offer a more complete account. Third, the Cannon-Bard theory may have overcorrected. There is now good evidence that visceral and somatic feedback does influence emotional intensity and quality, even if it is not the sole source of emotion. Remember, limitations of the Cannon-Bard theory include its oversimplification of brain structures, failure to explain emotional differentiation, and evidence that bodily feedback does contribute to emotional experience. Although the Cannon-Bard theory has been superseded, it planted the seed for modern neuroscientific accounts of emotion. The neuroscientist Joseph LeDoux, working in the 1980s and 1990s, described what he called the low road of fear processing. LeDoux showed that threatening sensory information can travel directly from the thalamus to the amygdala, bypassing the cortex entirely. He called this the dual pathway theory of fear. This allows the brain to generate a rapid fear response before conscious awareness has even registered the threat. This is sometimes called the quick and dirty route. It is fast and automatic, but imprecise. The cortical high road, in contrast, provides a slower but more accurate appraisal of the situation. LeDoux's model builds on the thalamic emphasis of Cannon-Bard, but replaces the cortex with the amygdala as the key subcortical structure generating rapid emotional responses. Remember, LeDoux's low road model describes a direct thalamus to amygdala pathway that generates rapid fear responses before conscious cortical processing occurs. The Cannon-Bard theory and LeDoux's extension of it have direct clinical applications. First, they help explain the rapid onset of fear and anxiety responses in clinical presentations, such as phobias and post-traumatic stress disorder. In post-traumatic stress disorder, The thalamus amygdala pathway can be triggered by sensory cues associated with trauma, generating a fear response before any conscious appraisal has taken place. This explains the automatic, uncontrollable quality of trauma-related flashbacks and startle responses. Second, the distinction between the fast, automatic low road and the slower, reflective cortical high road has implications for therapy. Cognitive approaches work on the cortical level, helping patients reappraise their emotional experiences. But when subcortical fear pathways are highly activated, cognitive strategies alone may be insufficient. This underpins the use of stabilization techniques and graded exposure in trauma treatment. Third, it helps explain why patients with anxiety disorders often report that their fear feels automatic and irrational. The brain has already responded before the rational mind has had a chance to evaluate the situation. Remember, the Cannon-Bard theory and LeDoux's low road model are clinically relevant to post-traumatic stress disorder, neurologic, phobias, and the rationale for combining cognitive and exposure-based therapies. Now, let's test your recall. I will read out 5 exam-style questions. After each one, I will pause for 10 seconds so you can attempt them before hearing the answer. Question 1. A patient with post-traumatic stress disorder describes feeling an overwhelming sense of terror when they hear a car backfire, before they have any conscious awareness of why. Which neural pathway best explains this response? LeDoux's low road. Question 2. A patient with a phobia of dogs freezes and experiences intense fear the moment they see one, despite knowing rationally that the dog poses no threat. How does the Cannon-Bard theory help explain this? The thalamus simultaneously activates the cortex and the body. Question 3. Why might a patient with severe anxiety struggle to use cognitive strategies alone to manage their fear response? The low road generates fear before the cortex has processed the situation. Cognitive strategies work at the cortical level and may be insufficient when subcortical pathways are dominant. Question 4. A patient describes feeling simultaneous dread and a racing heart the moment they receive bad news. Which theory does this best support? The Cannon-Bard theory. Question 5. A patient asks why their anxiety feels the same whether they are frightened or just cold and shivering. Which of Cannon's criticisms of the James-Lange theory does this illustrate? The non-specificity of visceral responses. Different emotional and non-emotional states produce similar patterns of sympathetic arousal. Let's summarise what we have learnt today. Cannon raised 4 criticisms of James-Lange theory. Visceral separation does not abolish emotion. Visceral responses are non-specific. The viscera lack sensory precision, and visceral changes are too slow. The Cannon-Bard theory proposes that the thalamus simultaneously activates the cortex and the body. the subjective emotion and the physiological response occur at the same time. A useful way to remember this is to think of the B in BARD. B stands for both. Both the emotional and the body response happen together. Limitations include the oversimplification of brain structures and the failure to explain emotional differentiation. LeDoux's low road model extended the Cannon-Bard approach, identifying the thalamus-amygdala pathway as the route for rapid automatic fear responses. This is directly relevant to post-traumatic stress disorder and phobias. In the next episode, we will explore cognitive appraisal theories, including the Schachter-Singer two-factor theory and Lazarus's appraisal model, which place thinking at the centre of emotional experience. Thank you very much for listening to this episode of MRCpsych on the Go Revision Essentials. I hope this episode helped to move your revision forward. If you have any questions or just want to continue the discussion, you can find me on LinkedIn at MRCpsych on the Go, spelled MRCPysch on the Go. This podcast is about making revision accessible. If you found it useful, liking and sharing it with others helps the goal more than anything else. That's it for today. I'm Dr. Alapas Ehrlicher, and as always, keep revising on the go.